Hello students, welcome back to the last video of this playlist. In this video, we will be solving question number 7, the last question of the most recent past paper of Mechanics 2, which is the October 2024 M2 paper. So let's get started with the last question of this paper. So here the question says a particle P has mass 5m and a particle Q has mass twice of m. The particles are moving in opposite directions along the same straight line on a smooth horizontal surface. Particle P collides directly with particle Q. Immediately before the collision, the speed of P is twice of u and the speed of Q is thrice of u. Immediately after the collision, the speed of P is x and the speed of Q is y. The direction of motion of Q is reversed as a result of the collision. The coefficient of restitution between P and Q is E. So part A is asking here to find the set of values of E for which the direction of motion of the particle P is unchanged as a result of the collision. Okay. So let's consider the sketch to understand the question in a better way. Look. So this is the straight horizontal plane. So here the particle P is moving and here the particle Q is moving. Okay, this is particle P, this is particle Q. So particle P is moving in this way and particle Q is moving on the other way. So initial speed of particle P, that is UP, it is given as 2u. Okay, and initial speed for particle Q, it is given as thrice of u. Okay, so and after the collision, the speed of particle P, that is v of P, it is equals to x, and the speed of particle Q after the collision, that is vq, it is y. Given in the question that the direction of motion of particle Q is reversed as a result of the collision. So after the collision, particle Q will be moving along this way. Okay, so we have to find out the range set of values of E, right? So E is basically coefficient of restitution. So coefficient of restitution can be found from the Newton's law of restitution, right? From Newton's law of restitution, we are considering this direction as positive. Okay, so E equals to speed of separation of particles over the speed of approach, right? Speed of approach of the particles. Okay, so at first consider the speed of separation. Since after the collision, okay, after the collision, particle Q is moving along this positive direction. Okay, particle Q is moving along the positive direction, but we don't know in which direction particle P will be moving after the collision, because the question didn't mention anything about direction of x. But the question in part A, it said that the motion of P should remain unchanged. That means the particle P will also should move along the positive direction. That's why speed of separation would be, okay, in this case, speed of separation would be y minus x. Okay, speed of separation would be y minus x, because they are moving along the same direction. That's why. And speed of approach, we can see that the particle P and Q were having head-to-head collision. That's why, since they are moving opposite to each other, okay, so that's why their speed will get added. So 3u plus 2u, so 3 plus 2, it is 5u. Okay, so this is the coefficient of restitution, E. Now we can cross multiply, so we will get y minus x equals to 5eu. Okay, so from there what we can figure out. Okay, so we have to eliminate y from here, y from this equation, in order to approach our answer. So for that we need another equation. So another equation we can form using the law of conservation of momentum. Okay, we have to eliminate y because the question said we have to find out the set of values of E. So E is there, that's fine. The motion of particle P, the direction of motion of particle P should remain unchanged. That means we have to do something with x. So x must be there with E. So x is there with E, that's fine. But y is to be eliminated. So to eliminate y, we should need another equation. So using conservation law of momentum, CLM, we can use m1u1, mass of particle P. It is particle P has mass 5m. It is 5n m. Particle Q has mass twice of m. So m1 u1, there is 5m times twice of u, 5m times twice of u, minus, we took right direction as positive, minus 2m times 3u. Okay, 2m times 3u equals to 5mx plus 5mx plus 2my. If I'm not wrong, the mass of particle P is 5m. So 5mx, that is the momentum of particle P after the collision, and momentum of particle Q after the collision, it is becoming positive as it is getting reversed. So 2my, positive 2my. Okay, from there m gets cancelled from both sides, so 10u minus 6u equals to 5mx. Okay, 5x plus 2y. Okay, we need a substitute for y, right? So make 2y the subject. 2y equals to 10u minus 6u, it is basically 4u. 4u minus 5x. So a substitute for y, it is 4u minus 5x over 2. Okay, now put this equation of y into the previous equation. The previous equation, in place of y, we will substitute that. So y minus x equals to 5eu. So y minus x equals to 5eu. So put it there. 4u minus 5x over 2 minus x equals to 5eu. So multiply both sides by 2. So you will get 4u minus 5x minus twice of x equals to 10eu. Okay, so we can cancel u from each side, from both sides. So 4u minus, okay, it's not 5u, it is basically x. 4u minus x. Okay, isn't it 4u minus x, the substitute for y? Okay, it's here, 4u minus x. Okay, no, we cannot ignore u. U will remain there in the equation. So 4u minus 5x minus 2x. So 5x minus 2x, it is 4u minus 7x equals to 10eu. Okay, now make x the subject from here, because we need to consider the direction of motion of particle P after the collision, that is x should be positive. Okay, that's why we are making x the subject. So 7x equals to 4u minus 10eu. Okay, so if you make x the subject, making x subject would give you 4u minus 10eu over 7. Okay, so since the direction of motion of P is unchanged, okay, unchanged, so x should be greater than 0, because it should be positive, because we considered to the right it is positive, and x should be positive because to the right direction we have considered positive. Okay, That's why x should be positive. Okay, so you will get 4u minus 10 eu greater than 0. Okay, so from there take 10 eu to the other side, so it less than, so it will get to the less than side, so 4u, so therefore e should be less than 2 over 5. Okay, e should be less than 2 over 5. Okay, and we know that the minimum possible value for e, Newton's the coefficient of restitution, it is basically 0. Therefore the set of the question has asked for set of values of e, so e should be greater than 0, less than 2 over 5. That's the set of values of coefficient of restitution. That's what part A of question number 7 has asked to find out. That's it. Fine. Okay, next is part B. In part B, the question says in the collision Q receives an impulse of magnitude 60 over 7 mu. So part B is asking to show that E equals to 1 over 5. The coefficient, the value for coefficient of restitution between Q and P, it is 1 over 5. That's what we need to show. Okay, so impulse. Consider the impulse. Impulse equals to, for part B, impulse on Q. So impulse on Q, it is acting on which direction? To the right direction. So we have taken the right direction as positive. So that means impulse on Q would be positive. So impulse on Q, it is equals to mass of the Q, particle Q. So mass of particle Q, it is twice of m. So 2m times v minus u, velocity of the particle Q after the collision. Velocity of particle Q after the collision, it is y, which is also in the positive direction. So y minus 3u. So that means it will become y plus 3u, right? So velocity of particle Q before the impact, it was negative 3u. So that's why y minus 3u, that would make it plus 3u. Okay, so from there we know the value for impulse on Q, it is given as 60 over 7 mu. So 60 over 7 mu equals to, multiply that 2, so 2y plus 6u, right? M cancels out, so you will get 60 over 7u equals to 2y plus 6u. Okay, we need the value for y, so 2y equals to 60 over 7 minus 6u. Okay, so 60 over 7 minus 6, that would give you 18 over 7u. So the value for y, it is 9 over 7u. We got the velocity of the particle Q after the collision, that is y. This is 9 over 7u. Now we can use 9 over 7u to find out the coefficient, the value for the coefficient of restitution. Okay, so to get the value for y, okay, to get the value for E, we can use the equation, this equation. Look, we can use this equation. Okay, so if we want to use this equation, the equation for the restitution, we need to know the value of x, right? The speed of particle P after the collision. So the value for x can be found from this equation. Okay, wait. The value for x could be found using CLM, this equation. We can use this equation to get the value for x. Okay, so y equals to 4u minus 5x over 2. So from there you can make x the subject. Okay, consider this equation. Consider this equation. If you consider this equation, if you take 5x to the left side, you will get 5x equals to 4u minus 2y. Okay, so Okay, let me write the equation for the ease of calculation. The equation is 2y equals to 4u minus 5x. 2y equals to 4u minus 5x. Okay, so we need the value for x. So 5x equals to 4u minus twice of y. So the value for x, it is 4u minus twice of y. It is 18 over 7. 18 over 7u over 5. So this is basically 4 minus 18 over 7 divide 5. It is basically 2 over 7, 7u. Okay, so the value for coefficient of restitution E equals to, what was the equation for E? It was y minus x over 5u. Y minus x over 5u. Y minus x over 5u. Okay, so y is basically 9 over 7u. 9 over 7u minus 2 over 7u over 5u. So what would be the value for E? 9 over 7 minus 2 over 7, it is just u, over 5u, that is basically 1 over 5, and that's the value of E, and that's what part B of question number 7 has asked to find out. Okay, to show, we have showed exactly E equals to 1 over 5. Fine. Okay, next is part C. In part C, the question says, after the collision, Q hits a smooth fixed vertical wall that is perpendicular to the direction of motion of the particle Q. Okay, so after the first collision, the particle Q hits a fixed vertical wall. Okay, particle Q rebounds, and there is a second collision between particle P and particle Q. So after being rebounded from the vertical wall, it will have a collision with particle P again. The coefficient of restitution between particle Q and the wall is 1 over 3. Okay, so part C here is asking to find, in terms of m and u, the magnitude of the impulse received by the particle Q in the second collision between P and Q. Okay, so after the first collision, okay, the particle Q, its direction is reversed, and then it will hit a fixed vertical wall here. Okay, so after hitting it, it will get again rebounded in the negative direction. Okay, so the coefficient of restitution between the particle Q and the wall is given as 1/3. So we will use that to approach our answer. Okay, so let's consider a blank page here. Okay, it's not possible. Okay, look, so particle Q, it will hit with a wall here. Okay, a fixed vertical wall, and then it will get rebounded. Okay, so this is the particle Q. It will hit the wall with the speed y. So the value for y we got earlier, it was 9 over 7u. 9 over 7u, this is the approach speed. So we have to find out the rebound speed of the particle Q. Okay, and the particle P, at this meantime, particle P will be moving along the way with the speed x. So speed of particle P at that moment, it is 2 over 7u. Okay, so consider for part C, using coefficient of restitution, E equals to rebound speed for direct impact, rebound speed over approach speed. So approach speed, we know that it is 9 over 7u. So therefore rebound speed after having impact with the wall, with the vertical wall, it is 9/7u. There is the rebound speed, there is the approach speed times E. The coefficient of restitution between the wall and the particle q, it is 1/3. So the rebound speed is 3/7u. We got the rebound speed. So rebound speed, it is 3/7u. With that speed, it will move in the negative direction. Okay. Now, particle P and Q will meet each other again. So as they meet each other again, let's have a look. Look, we will consider the conservation law of momentum again, because to consider the impact, to consider the impulse received by particle Q, we have to consider the velocity. Mass is twice of m, so twice of m times velocity after the collision minus velocity before the collision, right? So in that case, we need to know the velocity after the collision v. Okay, to find out the velocity after collision, we have to consider the conservation law of momentum between P and Q. Okay, so for that, for second collision, okay, for second collision, m1e1, the mass of particle P, it is 5m, its speed is 2/7u, if I'm not wrong. Yeah, it is x basically. So 2/7u, m1e1, and particle q is moving on the left direction, that's why negative. 2m times its rebound speed, it was 3/7u. So 3/7u, okay, equals to m1v1. So velocity of particle P after the collision, after the second collision, let's say it is w, okay, and velocity of particle Q after the collision, let's say it is z. So 2m times z. Okay, we don't know their direction. So 5, okay, m cancels from both sides. Okay, so 5w plus 2z, this is equals to 5 times 2, that is 10/7u minus 6/7u. Okay, so 5w plus twice of z, this is equals to 10 minus 6, it is 4. So 4/7u, multiply both sides by 7, you will get 35w plus 14z, this is equals to 4u. This is one equation. Okay, now our aim is to find out the value for z, which is the velocity of particle q after the second collision. Okay, now consider the law of restitution, E, between particle P and Q. So E equals to speed of separation over speed of approach. So for speed of separation, we need to consider the direction of the particle PQ after the second collision. Now this is very important concept, how you can identify it. Okay, so after the second collision, look, consider their mass. The particle P has mass 5m, and the particle Q has mass twice of m. If I'm not wrong, yes, the particle Q has mass twice of m. Okay, so which one has greater mass? Particle P, right? And during the approach speed, during the collision, the speed of particle Q was 3/7u. So which one had greater speed? Particle Q had greater speed. But you can see that the mass, since the particle P has greater mass, and compare it, it has very larger mass, right? Particle P has larger mass than particle Q, and the speed is just how much greater than P? The speed is just 1/7u greater, because the speed of particle P during the collision, it is 2/7u, but the speed of particle Q, it is 3/7u. So their difference is just 1/7u, but the difference is mass, it is 3m, right? So that means particle P is heavier, and in that case, the direction of motion of particle Q will get reversed in this collision rather than particle P. Okay, the direction of motion of particle Q will be reversed in this second collision. You have to figure it out from the mass and speed consideration. Okay, so after the second impact, the direction of motion of particle Q will be in the positive direction. Okay, so since it is in the positive direction, so Z would be positive. So while considering the speed of separation for the restitution, it should be Z minus W. Okay, you should be careful on that. Okay, this is the speed of separation and approach speed. They were moving opposite to each other, therefore approach speed will get added. Okay, approach speed will get added. Okay, so approach speed 1, that is x was 2/7, and for particle Q the approach speed was 3/7. So 2/7 plus 3/7 u, this is 2/7 u plus 3/7 u. So Z minus W, it is equals to 5/7 EU, right? So Z minus W, you will get 5/7 times restitution between particle P and Q. The coefficient, its coefficient is 1/5. Okay, so Z minus W, it is basically 1/7 U. Okay, now multiply both sides by 7. You will get 7Z minus 7W. This is equals to U. Okay, now this is basically the second equation, and we got the first equation, this one. We got two simultaneous equations. Okay, before we proceed to solving the simultaneous equations, let me tell you one thing regarding that Z minus W. Look, so Z minus W, the direction of particle P we considered it is unchanged, right? And direction of motion of particle Q, it is getting reversed after the second collision. That's why we have to consider Z minus W. Okay, now we have to solve the simultaneous equations. So we have here 7Z minus 7W. So let's multiply the second equation by 5 and then add it with the first equation. So first equation plus second equation times 5. Okay, so if you do so, what you will get, 35W plus 14Z, it is equals to 4U, and the second equation, it will become 35Z. So 35Z, it will become negative 35W. So negative 35W plus 35Z, this is equals to 5U. We have multiplied by 5. So 35W, negative 35W cancels out. You will have 49Z. This is equals to 9U, right? Okay, so Z equals to the value for Z you will have here. Okay, we got 4U there. So 4U plus 5U. Okay, we have multiplied that by 5. So you will get 9/49U, right? That's the velocity of particle Q after the second collision. Okay, now we have to find out the impulse received by particle Q. So impulse on particle Q, we are taking this direction as positive. So impulse on particle Q, this is equals to mass of particle Q, it is twice of m times Z, the velocity of particle Q after the collision, that is Z, minus its approach speed. What was the approach speed? It was in the negative direction, right? It was negative 3/7. Okay, so negative 3/7. So that would become negative negative 3/7, it will become positive then. Okay, the impulse received by Q, it is 2m times z, it is 9/49 plus 3/7u, 9/49u plus 3/7u, it is, okay, 2m times 9/49. Let's use the calculator. 9/49 plus 3/7, it is 30/49. So 30/49u. So its magnitude is basically 60/49 mu. That's the impulse received by particle Q in the second collision. Okay, the workings were too long for 3 marks, but still, for the second mark you have to do this whole calculation, and that's the answer for part C, and that's the end of this paper, that is M2 October 2024 paper. Fine.